Okay, so welcome back. Let's look at this the last set of problems here. So far, okay, numbers 16 and number 17. These are the kind of functions that we have studied for years and years, right? 18 and 19. All right, so these are vector valued functions. Maybe I should write it down somewhere here. Yeah, let's go ahead and do it. Numbers 16 and 17. These are real valued. Okay. Numbers 18 and 19 are called vector valued functions. These are, I mean, you know, this is a set, this is a point in two-dimensional space plane. This is in three-dimensional space, but these points are considered to be like the endpoints of vectors. And so you can identify a vector with every point of R2 and R3. And so these are called vector valued functions. I abbreviate in a function is some word we use very often. So FCN. Every time I write FCN, you can just think of this as a function. All right, and then how about numbers 20 and 21? Of course, you can have your own example. The important thing here is that the domain is R2 and the range is the set of all real, the codomain is a set of all reals. So that means you should use X and Y, you know, or S and T or whatever, two different variables that will give you a real number like xy minus y squared, or, you know, sine of x plus e to the y or whatever. But this has to be a real number. 21 is similar. Now the dimension of the domain is 3, so you have to have x, y, z. These are multi-variable functions, but the what comes out, the outcome, or the output is still a real value, right? So these are real value functions. Okay, and then we'll be studying of these things in chapter 4 and then chapter 5. Chapter 4 is differentiating these, and chapter 5 will start to integrate these things. So these are real valued functions. Let's make them plural. And also, but the 20 and 21, these are called multi-variable functions because you have xy or xy and z, right? So life is not as simple as in calculus 1 and mostly in calculus 2, because now we have these multi-variable functions, and that's exactly the point of calculus 3, okay? We take you to higher dimensions, literally, okay? A whole new world, and you'll never want to go back to where you used to be. Okay, number 22, now we have, ooh, look at that, the codomain, the domain and the codomain are both two-dimensional spaces, and that means you have xy here, and you have two components here, the x component and the y component, the first component and second component. These can depend on x, y, or both, okay? So, and again, your example may be different, but you have to have two components here, and you have to have x and y as your element in the domain. These are different. These are not real valued anymore, right? Because these, this and this, these are not just a set of reals. For instance, this is a vector. This is a vector. So these are called vector valued functions. But because the domain is also vectors, or the 2 or 3 dimensional spaces, these are called vector fields. Vector fields are vector valued functions defined on a vector space like R2 and R3. We will be studying these in chapter 6. Okay, look, this is an outline of this entire course. We are in chapter 2, and then these are the functions we'll be studying: 3, 4, 5, and 6. Okay, so this class is calculus, multivariable calculus. Right now, how is it different from what we used to have? Okay, so let me just give you a little picture of what you can expect. Here's a sine function. It goes like this, right? Y is sine of x. What do you do with calculus? Well, using calculus, you know, for instance, the value, or the, you know, the we can find the slope of a tangent line, for instance. That's our derivative, right? So you can do that. You can find the maximum and the minimum points, for instance. You can find the inflection points, okay? Those took place on the XY plane because we were talking about single variable functions, right? Now, here's what happens. When you have X and Y as your, both as elements of your, well, XY, the set of points on the plane, like the questions like of the type number 20, okay, functions of the type number 20. This will be the X and Y determining the Z value, right? So your graph is actually going to be something like that. This is f of x, y. In other words, for each point X and Y, you have, let's see, where are the pictures? Come on, there you go. Here's a point x, y, and x and y will determine the value z. Okay, so this is what a multivariable function is going to look like. Now, how fast is this changing? All right, well, that depends, okay? And instead of a tangent line, we'll be talking about a tangent plane, okay? And you can also be talking about things like in which direction should I go in order to maximize my rate of change, okay? And of course, because the rate of change, the derivative, depends on which way you are going, right? See, here, you only had one way of going because, I mean, x only increases. Well, I mean, you can make x go up or down, but it's still one-dimensional movement. Here, you have a two-dimensional movement. You can go in any direction you want, right? So the idea of the derivative sort of changes. Now we'll talk about the idea called the directional derivative. How do you find the maximum point? How do you find the minimum points? Okay, and then are there anything else that's going to happen? And the answer is, of course, yes, and we'll be talking about those. Okay, and then those are differential, and the first half of this course will be the derivatives, differential calculus. Okay, but that's not the only thing. So what happens if you have a function like this, a multivariable function, and if you want to find the area, not the area, the volume under the solid, and that is under the surface. Okay, well, close, I mean, clearly, this will be an integral, but this time it will be a double integral of f, which depends on x and y. And then we have to define, you know, what you're integrating over. And of course, that's going to be a region R, which we will use dA for differential. So these are the kind of things we'll be talking about double and triple integrals before we are finished with this. Okay. So that's sort of like the beginning part. Okay, it's not what I have described here so far is an introduction to calculus 3 or multivariable calculus. Okay, and I have talked about vectors, but I didn't exactly tell you what they are, and that's going to be our next segment. All right, so in the next couple of videos, we'll be talking about vectors in 2- and 3-dimensional spaces. All right, so you can take a little break. We'll come back and discuss what's in 2.1, the 2- and 3-dimensional vectors.